today we're going to be talking about how to calculate the resultant vector. So the first thing we're going to do is talk about how do we set up the problem. Okay, so we're going to draw the component vectors. Using the head to tail method. To scale. So this could be using the squares on a graph paper, or it could be using centimeters, or however scale that's easiest for you is chosen. Okay. Next, we're going to use a ruler and draw the resultant vector, and for us this should be a right triangle. Okay, right triangle. So then after we have it all drawn out, how to solve, we're going to use our geometry skills here, and we know that when two vectors or two lines are perpendicular to each other, we can use the Pythagorean Theorem. Which we know is a squared plus b squared equals c squared. So we're going to be using that to calculate our resultant vector. So let's do an example. An object travels 120 kilometers east, then 160 kilometers north. Calculate the resultant displacement. Alright, so normally I'd be using graph paper, but I'm just going to do a quick sketch here using our relative size of our vectors. So first things first, we have north, south, east, west, and then I'm going to draw 120 kilometers to the east, 160 kilometers to the north, and now I know that that is a right triangle that I can make here because these two vectors are perpendicular. So I'm going to use a ruler and draw my resultant vector from the tail of the first to the head of the second, and this is my displacement resultant vector. Okay, so I'm going to solve that. So a squared plus b squared equals c squared. So here we know that the sides of our right triangle essentially is how we can think about it, are a and b. So 120 kilometers squared plus 160 kilometers squared equals c squared, or our resultant squared. So I'm going to square these and add them together, and I get 40,000 kilometers squared equals c squared. And in order to solve this, I'm going to square root both sides so I can get c by itself. And when I square root 40,000 and kilometers squared, I end up with 200 kilometers equals c. So this is going to be my resultant displacement vector. So don't forget though, when we're solving these problems, we need to have a direction. So must include the direction of the resultant vector. So for this question, our final answer is 200 kilometers northeast, because it's just between the north and the east. Okay, now let's look at a couple more. You should have these questions given to you, and then we're going to do this on graph paper to make sure that we are to scale. Again, we're going to do the same north, south, east, west to keep our directions consistent. So number 1, a vector has an x component of 5 meters per second west and a y component of 7 meters per second north. What is the resultant vector? Okay, well, I know I'm going to have to end up traveling to the west, and I'm going to say that 1 square is representing 1 of each unit. Okay, so how about I start right about here. Let's give it a try. So 1, 2, 3, 4, 5 meters per second. This is my component, my velocity vector in my x direction, which is 5 meters per second west. And then I have a y component of 7 meters per second north. So 1, 2, 3, 4, 5, 6, 7 north. Trying to draw it on the line there, excuse me. Here we go. So this is my velocity component in the y direction, 7 meters per second north. Well, I know that this is a right triangle, or it can make a right triangle, so I'm going to draw my resultant vector using the head to tail method. So this is my velocity resultant vector. So a squared plus b squared equals c squared. I've got a 5 meters per second squared plus 7 meters per second squared. Oops, excuse me. Alright, I fixed that. 7 meters per second, and the whole thing is squared, equals c squared. Okay, so I'm going to square these and then add them together, and I get 74 meters squared over second squared, because remember, whatever you do to the number, you also do to the unit, equals c squared. So 5 squared is 25, and 7 squared is 49. So add those together, and that's how I got 74. And then in order to get c, or my resultant, by itself, I'm going to square root both sides. So 74 meters squared per second squared, square rooted, is 8.60 meters per second. And then I need a direction. So if I look at my cardinal direction of which way this is facing, this is going to be northwest. So this is my final answer for my velocity vector resultant. Okay, now let's look at the second question. An object travels 4 meters east and then 5 meters south. What is the resultant vector? So I'm going to travel first 4 meters east, 1, 2, 3, 4, and remember my scale here, I just chose 1 of whatever my unit is representing by 1 square in my graph paper. So this is my displacement vector in the x direction, which is 4 meters east, and then I'm going 5 meters south, 1, 2, 3, 4, 5, and this is my displacement in my y direction. All right, and now I'm going to draw in my resultant vector here, same way that I did before. Okay, so I know that this is going to be my resultant vector for my displacement. So I'm going to slide my paper over. A squared plus b squared equals c squared. We're going to plug it in. 4 meters squared plus 5 meters squared. Ooh, I did it again. Alright, sorry about that. 5 meters squared. I know that's going to equal c squared. So I'll write it real small. I'm out of room, but c squared. So now let's go ahead and square these and then add them together. So 4 squared is 16 plus 5 squared, which is 25. So 16 plus 25 is 41 meters squared. Remember, whatever you do the number, you do the unit, equals c squared. So in order to get c by itself, I'm going to square root both sides. So 41 square rooted in my calculator is 6.40 meters, and I need a direction, so I went east and then I went south, so south, east. And that is how we are going to solve for our resultant vectors using our x and y components.